Hi. Today we shall be developing, sorry, hi, hi. Today we shall be developing a stationary variable. Just 1 minute. Today we shall be developing stationary variable from non-stationary variable. Sorry, from non-stationary variable, and we shall use this stationary variable in different time in different time series model, such as var, then arch and garch, and so on. So first we shall convert a variable into stationary. Then we can use this stationary variable into different time series model, such as var, then arch, garch, and so on. Okay. So first I see my variable. The variable is here. You can see the variable. So you just wait 1 minute. I make it adjust slightly. Sorry. Okay. So this is my variable. You can see GDP, gross domestic product. It is my variable. Excuse me, and I can make it zoom for you. That is the zoom GDP variable, and the sample size is from 1960 until 1999. And I shall first check whether our GDP variable is non-stationary or not. If it is non-stationary, then I shall convert this variable into stationary, and when the variables are converted into stationary, then we can use this stationary variable in time series model, such as var, such as arch and garch, and so on. Okay, so what I do, I open this variable. As a result, you can see the variable. It is the GDP, right? Gross domestic product, and starting from 1960 until 2012, right? So that is my data from 1960 until 2010. That is my data. And here, but here out of 51, here my sample is from 1960 until 1990. So here my sample, my range is 1960 until 2010, but out of this total range, my sample is from 1960 to 1990. That means I shall be using data until 1990. Excuse me. Okay. So first I check whether our variable is non-stationary or not. That I check first. Okay, so first I check graphically. Graphically, first I check whether our GDP variable is non-stationary or not. So I go to quick, then I choose the graph, right? I can make zoom for you. Okay, I choose the graph, right? From here, you can see I choose the graph. Okay, then you can see I can make it zoom for you. Here I put GDP, gross domestic product, that I write here, right? So that I write here. Then I press OK. Okay, so here I choose lines and symbols, right? Then I press OK. So here is the data, our GDP data. It is gradually going up from 1960 until 1990. It is gradually going up, meaning that the data is not stationary. It is non-stationary. Okay, so this one is the graphical presentation. It is the graphical presentation. Now we have to check it using test whether our variable is really non-stationary or not. And here uh, we shall be using correlogram, and also we shall be using actually Ljung box. We can call it LB statistics, that we shall be using to test whether our variable is stationary or non-stationary. Okay. So now, now, we can use this June box statistics, or we can call it LB statistics. Same meaning. So I go to quick, then I choose series statistics, then I choose correlogram, right? It is here, correlogram. Then the variable name is GDP, right? That I put here. I can make it zoom for you. You can see I can put series name GDP. So then I want to run. Okay, here there are two things. Label, I can make it zoom for you. So here is three things. One is label, then first difference. That means after first differencing, what happens? And this one is the second difference, meaning that after converting the variable into second difference, then the variable is stationary or not. And what about at level? Meaning that data has not been into first difference or second difference. So this one is the original data. Original data, that is called label. And suppose if I choose first difference, then the EVIEWS software will automatically convert the variable into first difference, and then they will check whether first difference variable is stationary or not. Or if I choose the second difference, then our software will automatically convert the variable into second difference, and then they will check whether second difference variable is stationary or not. But here first I choose at label, meaning that the data that I have, original data that I choose first. And here I choose lag 10. Why? Normally the guideline is, normally we take 1/3 of the data as a lag. So our data is almost 30, so I take 1/3, that is 10. So that is some guideline. Normally we take 1/3 of the sample size. Okay, now we are set. We can proceed for testing at label. I click OK, then I click OK, I click OK. So the result is coming up of the correlogram. It takes some time because my computer is very slow, so it takes some time. And also I personally also very slow. I talk slowly all the time. I'm sorry for that. Okay, it's coming up. Where is the result? Is it coming up already? So long. Okay, it has come up here actually. Okay, it is the outcome of the correlogram. You can see from here. I make it big for you. Okay, it is the outcome. So you can see the autocorrelation, right? You can see autocorrelation, this one. And this one is the autocorrelation, right? So what is this? Suppose I talk about this one. This one means 0.766 means actually this one. Then what about this one? This one, what about this one? 0.771, and that is autocorrelation coefficient. It is actually here, this one. Then what about the last one? This is 0.048. That is the autocorrelation coefficient. This one means actually this one, right? So here you can see autocorrelation coefficient is gradually going down. As a result, here it is also gradually going down. So here going down, as a result here is also going down. And here I have taken 10 lag. So you see from here, lag 1, lag 2, lag 3, lag 4 until lag 10. And normally I say when the autocorrelation gradually goes down, meaning that data, our variable, probably non-stationary. So I'm telling again, when the autocorrelation, it is the autocorrelation, right? AC. When it goes down gradually, meaning that probably our data is non-stationary. And here is the Q statistics. You can see the Q statistics. It is the Q statistics, right? And it is the corresponding probability. It is the corresponding probability of this Q statistics. Okay. Now, what is our null hypothesis? That we have to check first. Our null hypothesis is data is stationary, and our alternative hypothesis is data is not stationary. Excuse me, I have some problem in my throat. Okay, so our null hypothesis is data is stationary, and alternative is data is not stationary. Okay, and here you can see. Okay, and here we shall be using Jung box test. Here our task, we shall be using Jung box statistics to test whether our variable is stationary or not. Okay. Okay, now we see from here. Okay, and here you can see excuse me, and here we can see the Q statistics. The Q statistics is how much? Here you can see our Q statistics is here, right? And here we choose the last one. The last one of the Q statistics. So I go down. So I choose this 95.269. I choose the 95.269 of Q statistics, right? And I choose the corresponding probability value. That means P value. So here the probability value is 0, meaning that less than 5%, meaning that we can reject the null hypothesis, meaning that we reject the null hypothesis and accept the alternative, meaning that our data is not stationary, because we can reject the null hypothesis and we accept the alternative. Why? Because our p-value is less than 5%. It is here. So and the thing is that what is the guideline? The guideline is normally if the p-value or probability value is less than 5%, we normally reject the null hypothesis. But if the p-value more than 5%, we do not reject null hypothesis, rather we accept null hypothesis. But here the p-value is less than 5%, so we are rejecting null hypothesis and accepting alternative hypothesis, meaning that data is not stationary. So we cannot use this data in the time series model. Normally time series model need stationary data, and here our data is non-stationary. Okay, and also we can see from here there is another symptom, the autocorrelation. I just make it big. You see from here, this autocorrelation, actually you can see there is two lines. There's one line, can you check this line and this line? right? One line and one line, right? There's two things. Okay, normally when this, we call it spike. We call it spike. Spike means S-P-I-K. We call it spike. I write it here, spike. We call it spike. And normally when this spike, just 1 minute, when this spike are outside this two line, you can see here is one line and here is one line, and when the spikes are outside this line, meaning that data is not stationary. That is one symptom. That is one symptom. When the spikes are outside the line, we can suspect that, we can assume that our variable is not stationary. And that is the graphical way, and we have just proved that Q statistics, it is not significant, is significant because p-value is less than 5%, meaning that indeed the variable is not stationary. Okay, now our target is to convert the variable into stationary. Okay, now the question is that how to convert a variable into stationary. One way is to convert a variable into stationary. Stationary is first differenced. That means we shall convert our variable into first difference, and probably after that our variable will become stationary. Okay, so we convert our variable now, then we check what happens. Okay, we convert our variables, and it is our variable, you can say our GDP variable, right? Okay, our GDP variable is here. Here is our variable. Now we shall convert the variable into first difference. How? Okay, so here we have a variable called GDP. I create one more variable, suppose that is called DGDP. Suppose I choose new object to create a new variable, new object. Then here I choose series, right? Series, and here I put DGDP, right? So I can make it zoom for you. You can see I choose series, then I choose DGDP, right? That means this one is the new variable that I am creating now. I am creating this new variable now, that is DGDP. Okay, and okay, so the new variable has been created, that is DGDP. Excuse me. And the question is that what does mean by DGDP? Actually, DGDP means first difference of GDP. That is called DGDP. Okay. Now what is called DGDP? DGDP means here I am writing the command. DGDP means D by GDP. So that is the command in EVIEWS. That means the GDP will convert to first difference automatically, and this one is the command. And after writing the command, you just press on the enter. You just press on the enter. As a result, GDP will be converted into first difference, and the name of the new variable is dGDP. Okay, so now we can check. Here is our variable. I can make it zoom for you. You can see. Here is the variable dGDP, and this one is the GDP, and this one is the dGDP. And here GDP, the data is non-stationary, and here the dGDP, actually first difference of GDP. Now we want to check whether this dGDP is stationary or not. Okay. Okay. So okay, what I can do, I can show you the data. I can open and I can show you the data. You can see that is our new variable dGDP, right? First difference of GDP, and you can see the data from here, right? You can see the data from here, right? And here we are using until 1990, right? So that is our data. Okay, now I check using graphically. I check using graphically whether this first difference variable has become stationary or not. Okay, so I go to quick. I choose the graph, right? I choose the graph. Then here I put, making it zoom for you. Here I put dGDP, right? I put dGDP. Then I press OK. Then here I choose line and symbol, right, and press OK. Okay, now you see the variable is dGDP, and it is from 0, right? 0, and the variable is like this, right? The variable is like this. It is straight, right, on the 0. Then I can say that probably our first difference variable has become stationary because it is on the 0, right? So the data is not like this or not like this. The data is not going up or is not going down, and there is no trend. So I can say that probably our data has become stationary. But we can check it using our statistics, that whether our variable is really stationary or not. Okay, then I check it. I go to quick. Then I choose the series statistics. Then I go to the parallelogram as before, and the variable name right now dGDP, right? I can make it zoom for you. The variable name is now dGDP. Then I press OK. And here I choose at label. because the variable has been already converted to first difference. So here I select the label because the variable has been already converted to first difference, and so we can check it. And lag, here I choose 10, right? Lag I choose 10, so I can show you the whole things. Here I choose label and the lag I choose 10. Because our sample is 30, I choose 1/3 of the sample as a lag. Okay, then I press OK. So this is the outcome of the statistics. You can see from here. This is the outcome of the statistics comes up, right? Okay. And you can see from here that is the things, the result has come up. So here is it, and here is the result of correlogram of DGDP, right? It is DGDP, the correlogram of DGDP. I can make it zoom for you. You can see the correlogram of not GDP. It is DGDP, meaning that first difference of GDP. And here is the autocorrelation coefficient, and they have become so small, right? Become so small, and sometimes become 0, right? Some become 0, right? All are very small. And we have 10 lakhs, you can see all the 10 lakhs. So they have become very small. As a result, here is also very small. You can see the data almost 0. So there is no spikes. There is no spikes, right? All spike becomes 0. So here is only this one, actually this one, and this one, actually this one, right? And other becomes 0. You can see other becomes 0. So there is no spike. We cannot see any spike. But normally, what is the guideline? If the spikes are within this 2 line, then we can say probably the data is stationary, right? But here one is outside the spike. This one is outside the line. So here one spike is outside the line. So normally the guideline is all spike should be within these 2 line. But the thing is that this one is the graphical presentation that cannot make anything conform. But we can make it conform by using our statistics, and that is called what statistics? That can make us conform by using Jung box, that is LB statistics, whether our variable is stationary or not. And what is our null? Null is data is stationary, right? That is our null hypothesis, and we can check from here, right? We can check from here. You can see from here. Okay, and this is the Q statistics, right? This is the Q statistics, and we choose the last one. We choose the last one, 7.3602, and corresponding probability value. These are all probability value, And here out of Q statistics, I choose the last one, 7.36, and the corresponding probability value. The probability value is 69.1%. 69.1%, which is more than 5%, so we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that data is stationary. So meaning that our variable, that is dGDP, can be used for data analysis, right? Such as I can run the regression line, and I can do the VAR model, I can do the arch model with this dGDP variable, because this variable has become stationary after first difference. Okay, suppose if this variable does not become stationary after first difference, then we should do second difference. We should do second difference to make it stationary. Make it stationary. Meaning that as long as the data is not stationary, we should continue to do first difference. If not, then we should do the second difference. And then we can use that data for time series analysis. So that is the normal guideline. But in our model, after first difference, the variable has become stationary. So our first difference data, such as dGDP, we can use this dGDP for analyzing the data. Thank you very much for being with me for a while.